Hello, welcome back once again. Today we have this interesting exponential equation. We have x raised to the power of y is equal to y to the power of x, and here we're going to solve for x and y values, right? But we're given that x is not equal to y, right? If x is equal to y, then we have infinitely many number of solutions, right? X can be 3 and y can be 3, x can be 1 and y can be 1, x can be 2 and y can be 2, and so on, right? But in this video we're going to solve for values of x and y where x is not equal to y, right? Okay, now we see that we have just a single equation with two different variables. So this is an example of Diophantine equation, right? Okay, so let's get started. Now we're going to start with the following substitution. So we're going to let x equals k times y, right? So k is integer. Okay, so now since we have x is equal to k times y, so we're going to substitute the value of x in terms of k and y into the original equation. Remember, we have x raised to the power of y. This is equal to y raised to the power of x. Now since x is equal to k times y, so here x is going to be k times y raised to the power of y. This is equal to y raised to the power of here x is k times y, right? Okay, cool. Now we're going to raise both sides to the power of the reciprocal of y to get rid of these y powers. Okay, so here we have k times y raised to the power of y whole raised to the power of 1 over y. This is equal to y raised to the power of k times y raised to the power of 1 over y, right? So we can see something really nice going on. So if you multiply these powers together, y will get cancelled with y. If you multiply these powers together, y will get cancelled with y. So we're going to have ky, right? This is equal to, so this side we're going to have y raised to the power of, that would be k. Okay, cool. Now what are we going to do next? Let's rewrite this equation as y to the power of k is equal to k times y. Now let us divide both sides by y. So divide this by y and divide this right hand side by y. So by so doing, we're going to have from the right hand side y get cancelled with y, and from this left hand side, remember this y has a power of 1. So we apply this property, a to the power of m divided by a to the power of n. We have the same base, right? So we're going to subtract the powers, a raised to the power of m minus n. So this is going to be y raised to the power of k minus 1. This is equal to k. Now to solve for k, we raise both sides to the power of 1 over k minus 1. So that is going to be y raised to the power of k minus 1 whole raised to the power of 1 over k minus 1. So that we can get rid of this power right over here. So this is going to be equal to k raised to the power of 1 over k minus 1, right? So multiply these powers together, this get cancelled with this, and from here we have our solution for y in terms of k. Y is equal to k raised to the power of 1 over k minus 1. Interesting. Then what is x? Remember, x is equal to k times y. So this is going to be equal to k multiplied by y's value is k raised to the power of 1 over k minus 1, right? So remember this property that a raised to the power of m multiplied by a to the power of n. This is going to be a raised to the power of m plus n. So remember there's a power of 1 here. So we get x is going to be equal to k raised to the power of 1 plus this power here, 1 over k minus 1, right? So this is going to be equal to k raised to the power of 1 here is same as k minus 1 over k minus 1. Then plus 1 over k minus 1. So you can see k minus 1 plus 1 will give us k. So here we see that x is equal to k raised to the power of k over k minus 1, right? Okay, so here we have general solutions for x and y, and we know that k is equal to 2, 3, 4, 5, 6, and so on, right? Can k be negative? Maybe k negative may be a solution, but here we are interested on the positive integers for k. Okay, Now, we know why k is not equal to 1 is because the denominator here is going to be 0, and we have division by 0. which is undefined, right? So k cannot be equal to 1. Now we have some solutions. When k is equal to 2, we have the following solutions for x. X is equal to 3 root 3 and y is equal to root 3. Then we have another solution when k is equal to 3. These are some solutions, okay? So we have x is equal to, so that is when k is equal to 3, so x is equal to, that is, what do we have? Oh, sorry, I think I made a silly mistake. So when k is equal to 2, this is not the k, and this is not the x and y value, so it's going to be x is equal to 2, right? And then y is equal to 4. Yes. So when k is equal to 3, that is when we have 3 root 3 and y equals root 3 and so on. So once you plug in the values of k, 2, 3 and 4, you keep getting solutions. So for the only integer solution for x and y, we have 2 and 4. Then when we talk about real solutions for x and y, they are infinite, right? So we have infinite number of solutions. Okay, what about the case when k is negative? Can that also be a solution? I don't think that should be a solution, right? Because we're going to have complex solutions, right? So this general solution is valued when k is positive integer, okay? So we have our general solution right over here. Y is equal to k to the power of 1 over k minus 1, and x is equal to k to the power of k over k minus 1, where k is equal to 2, 3, 4, 5, 6, and so on, which is infinite, right? Thank you for watching. Please, if you really enjoyed this video, kindly subscribe, also like, comment, and share.